Alright, Assalamu alaikum and very good evening. My name is Ali. Today I will give a description about our lab for fluid mechanics, which is impact of a jet. So, water turbines are widely used throughout the world to generate power. In the type of water turbine referred to as a Pelton wheel, one or more water jets are directed tangential to vanes or buckets that are fastened to the rim of the turbine disc. The impact of the water on the vanes generates a torque on the wheel, causing it to rotate and develop power. Although the concept is essentially simple, such turbines can generate considerable output at high efficiency. Powers in excess of 100 megawatt and hydraulic efficiency greater than 95% are not uncommon. It may be noted that Pelton wheel is the best suited to conditions where the available head of water is great and the flow rate is comparatively small. So we have two main objectives here. First is to measure the force generated by a jet of water striking a flat plate or a hemispherical cup. And second, compare the result with the compute momentum flow rate in the jet. So this is the description of our apparatus. This figure shows the arrangement in which water supplied from the hydraulic bench is fed to a vertical pipe terminating in a tapered nozzle. This produces a jet of water which impregnates on a vane in the form of the flat plate or hemispherical cup. So, procedure. First, the apparatus is first level and the level brought to the balanced position with the jockey weight at zero settings, not the weight of the jockey, and the following dimensions: diameter of the nozzle, height of the vane above the tip of the nozzle when the lever is balanced, and the distance from the pivot of the lever to the center of the vane. Then water is then admitted through the bench supply valve and the flow rate increases to the maximum. The force on the vane displaces the lever, which is then restored to its balance position by sliding the jockey weight along the lever. The maximum flow rate is established by collection of water over time and interval. Further observations are then made at the number of reducing flow rates. About 8 readings should suffice. The best way to set the conditions for reduced flow rate is to place the jockey weight exactly at the desired position and then to adjust the flow control valve to bring the lever to the balanced position. The condition of the balance is thereby found without touching the lever, which is much easier than finding the point of balance sliding jockey weight. Moreover, the range of the setting of jockey position may be divided neatly into equal steps. So let's talk about the results. Here is the sample calculation for our lab report. I won't go into detail because we don't have too much time. And these are the results we got from each of the calculations. And let's talk about discussion. And from this graph, it's clear that the force produced on each vane is proportional to the momentum flow in the jet as it strikes the vane. For the flat plate, the slope of the graph is 0.97 as compared with the ideal value of 1. The discrepancy is possibly due to systematic experimental errors such as small error in the measured value of nozzle diameter. A further possibility lies in the behavior of the jet after striking the vane. It forms a radial sheet which impinges on the inner wall of the surrounding cylinder and then divides some of the water flowing down the cylinder wall and the rest flowing upwards. Although the visibility is impaired by the spray which is generated, it does seem that some water falls onto the top side of the vane. This would have the effect of producing small momentum force in downwards direction, so reducing the net force in the vane. For hemispherical cup, the slope of the graph is 1.92, so that the F is equal to 1.92 J. The maximum possible force shown in equation to be 2J, which occurs when the jet is deflected through the 180 degree without energy loss. The ratio between the measured force and theoretical maximum may be regarded as an efficiency of the vane, 0.96 in this case, and will always be less than 1 because losses will always occur in the practice. So that's all for our lab report. Thank you so much and have a good day.